videos. And this results in an invitation to spend 4 months in a cancer research lab trying to shatter cancer cells. This is our setup in the lab. You can see the microscope with cancer cells on it. Here's the plasma tube, and here is my little frequency control box. So first we attack pancreatic cancer. Take a good look at this slide, because the next one will look quite different. After we treat these cells, they change their shape and size, and they begin to grow long, rope-like structures out the sides. They look something like antennas. I call them bioantennas, for biological antennas. It's as if the cancer cells are trying to tune in to our signal. It also turns out this is the beginning of a process of destruction for cancer cells. We now know that cancer is vulnerable between the frequencies of 100,000 hertz and 300,000 hertz. So now we attack leukemia cells. Leukemia cell number 1 tries to grow a copy of itself, but the new cell is shattered into dozens of fragments and scattered across the slide. Leukemia cell number 2 then hyperinflates and also dies. Leukemia cell number 3 then tries to make another cancer cell. The new cell is shattered and the original cell dies. But killing a handful of leukemia cells is not enough for a patient. What kind of numbers can we do? In repeated controlled laboratory experiments, independently assayed by the 2 top experts, we killed an average of 25% to 42% of the leukemia cells, as high as 60%. They also determined that we slowed the growth rate of the cancer by as much as 65%, so a double effect. Now we attack ovarian cancer cells. This is a more distant shot. Here you see brackets coming up around the cells, showing groups of ovarian cancer cells which are being destroyed. You can see by the end of the video that a great many ovarian cancer cells were destroyed. Now we attack pancreatic cancer once more. In the center of the screen is a clump of pancreatic cancer cells, like a microtumor under the microscope. We turn on our electronic signals, and the tumor shrinks and is broken up. The cells are disconnecting, disaggregating, the opposite of forming a tumor. And some of the cells are destroyed. In our most recent work, we attacked the deadly organism MRSA. MRSA is particularly dangerous because it's resistant to many common antibiotics. Thousands of people die every year from MRSA. They have drugs for it, but they have very toxic side effects. We found that our electronic signals could actually eliminate antibiotic resistance in MRSA. Then by adding a very small amount of a common antibiotic, we were able to kill MRSA and slow its growth rate. Since I was a 17-year-old high school student with twin interests in both music and science, I never imagined the two would come together in a cancer research lab. I now believe that the future cancer treatment rooms for children will be a very different place. It will be a pleasant place where children gather and make new friends. They probably won't even know they're sick. They'll draw pictures, color in their books, play with their toys, all the while unaware that above them are beautiful blue, pinkish plasma lights emanating healing, pulsing electric fields, shattering their cancer painlessly and non-toxically, one cell at a time. Thank you.